Assalamualaikum. Hi guys. In this video, we are going to focus about variation of boiling point and melting point to the molecular structure and types of bonding, and last but not least, intermolecular forces for selected elements in period 3, group 1 and group 17. So we are going to learn about the trend first. The trend for melting point and boiling point kita akan discuss for period 3 dahulu. So you can see that this is the melting point for period 3 and this is the boiling point for period 3 elements. Variation of melting point and boiling point kita akan discuss in period 3 based on 3 parts. The first one about metallic structure adalah daripada Na until Al. Seterusnya, second part about silicon, and the last one we are going to discuss about simple molecular structure from phosphorus until argon. Let's go with the first part, metallic structure sodium to aluminium. Kita talk about the strength of metallic bond is inversely proportional to the size of positive ion. So maknanya strength of metallic bond is proportional to the number of valence or delocalized electron. Sekiranya awak diberi elements, maknanya kita akan lihat how many valence electrons the element has. So for example, we know that sodium ada 1 valence electron, magnesium has 2 valence electrons and aluminium has 3 valence electrons. All of these are depending on their respective groups. So daripada sini, kita akan tentukan strength of metallic bonding. So, from the previous video, we've learned if the element has more valence electrons, it means that stronger metallic bonding and higher melting or boiling point. For example, dalam kes ini, aluminium has the highest number of valence electrons. Automatically, kita boleh lihat trend dekat sini. That's why melting point or boiling point untuk aluminium yang paling tinggi sebab dia ada stronger metallic bonding. So itu adalah first part. Next part, kita go for the gigantic molecular structure for silicon. So silicon is made up of atoms that is tetrahedrally covalent bonded to other silicon atoms at neighboring lattice site. So apa maksud this one? Dia dibentuk oleh Si atoms yang sangat banyak dalam bentuk tetrahedral dan menghasilkan a crystal that is essentially one gigantic molecule. So macam mana rupa dia? Rupa dia like this one. So you can see that this one like tetrahedral. You got another one, another tetrahedral shape for silicon atoms. And another one more and another one more. Kalau saya ada banyak, dia akan bersambung-sambung-sambung sampailah awak nampak dia ada essentially a gigantic molecular structure of silicon atoms. So, melting point and boiling point of silicon is very high because we have strong attractions between these covalent bonded atoms. Kita ada strong covalent bond here. So maknanya kita perlukan high energy to overcome this strong covalent bond. Hence, high melting or boiling point. So itu sahaja untuk explanation for silicon. Awak kena mention dia punya tetrahedrally arrangement between silicon atoms yang membentuk gigantic structure. Next one, we have the third part, the simple molecule structure daripada elemen phosphorus until argon. So these are mainly the non-metals that exist as molecules. Bila dia exist sebagai molecules, maknanya awak kena tahu dia punya simple formula. So simple formula for phosphorus, it will exist as P4 molecule, sulfur as S8 molecule, chlorine as diatomic molecule Cl2 dan argon kerana dia sudah stable from group 18, it will exist as monoatom Ar. So all these non-metals have weak van der Waals forces. So bila dia ada weak van der Waals forces, maknanya yang kita belajar daripada video sebelum ni, van der Waals forces is proportional to the molecular size. Kalau size dia besar, maknanya van der Waals forces dia paling kuat. Kita akan lihat in terms of relative molecular mass. So, we got the order of molecular size. Dalam case ini, argon. Ini kan dalam the same period. Period 3 maknanya across the same group. Kita akan guna this triangle. So, size dia akan makin kecil. So, that's why the order of molecular size for argon is the smallest one. Hence, bila size dia paling kecil, maknanya dia punya order of melting point or boiling point yang paling kecil. Sebab ini adalah non-metal ya, kita tak cakap tentang metal. So, dia akan ada order yang sama. Tapi dalam case ini kita put as element. So, you can see that the melting point and boiling point for these non-metals dalam variation in this part. So, settle untuk discussion about period 3. Now, we go for group 1. So, group 1, you can see from this picture, melting point and boiling point decreases down the group. You can see clearly from the values here. So, why is this happening? We should know that as we go down the group, the size of atom increases. Kita akan gunakan ansas di mana segitiga dia menegak. So, this cause the electrons to be less attracted to the nucleus. Maknanya attraction between nucleus and valence electron sangat lemah. So, maknanya metallic bond is weaker. Dalam kes ini, we talk about metallic bond kerana group 1 adalah metals. So, less energy is needed to overcome the weaker attractive forces between metal atom. Therefore, we got lower melting point and boiling point. So, itu reason dia untuk group 1. And last part, we go for group 17. So, group 17, you can see that melting point and boiling point increases down the group 17. Dia opposite with group 1. So, why is this happening? When going down the group, we know that size of atom increases. Macam case yang sama tadi, kita ada segitiga like this one. And the van der Waals forces become stronger since the strength of van der Waals forces is directly proportional to the size of atom. So, kerana we talk about group 17, we are focusing on van der Waals forces. And from before, in the previous video, van der Waals forces is directly proportional to the size of atom. So, kalaulah awak punya atom tu besar, maknanya van der Waals forces dia sangat strong. So, when going down the group, kita faham size dia sangat besar. So, that's why dia punya van der Waals forces paling kuat. So, more energy is needed to overcome the strong attractive forces, iaitu van der Waals forces between the molecules. Hence, higher melting point and boiling point. So, that's it for the explanation about melting point and boiling point in group 17. So, I hope you are clear with a lot of explanation based on these last two videos for chapter 4. It's very easy. You just need to understand the theory and concept from the previous chapter 3. You've learned about size based on layout, pizzas and ansas. So I hope you enjoy with this video. Thanks for watching. Bye.